Okay, thank you so much for watching. Now today we have lesson 14.2, trend lines and predictions. And the essential question is, how can you use a trend line to make a prediction from a scatter plot? Okay, we're going to watch the video first.
Your class goes on a trip to the Natural History Museum to see an exhibit on the Argentinosaurus. The Argentinosaurus was the largest known dinosaur. Although this giant wasn't a meat eater, it would still be a pretty scary sight if you saw one coming down a dark alley. In 1987, an Argentinosaurus bone was found that measured over 150 centimeters. Pretty big, huh? And that's only part of its leg. The museum exhibit includes a scatter plot that shows the recorded lengths of similar bones for various other dinosaurs compared to their weights. Your guide asks you to tell her how much an Argentinosaurus would weigh. Oops! Well, you won't be able to weigh the dinosaur, but maybe the scatter plot will help. In this lesson, you'll learn how to use a trend line to make a prediction like this from a scatter plot.
So I finally get how they predict the weights of the dinosaurs. They use a scatter plot to estimate. So those are all just estimates, okay? So
when a scatter plot shows a linear association, you can use a line to model the relationship between the variables. A trend line is a straight line that comes closest to the points on a scatter plot. Joyce is training for a 10-kilometer race. For some of her training runs, she records the distance she ran and how many minutes she ran. The table shows the data she recorded. How can we use the data to make predictions about Joyce's race? First, let's make a scatter plot of Joyce's running data. The first point, a distance of 4 miles in a time of 38 minutes, has already been plotted. Now drag the points to the scatter plot to represent the two highlighted sets of data.
So 1, 7, 1, let me see, 1 and 7. 7 is going to be right around there. And then 5 and 35 and 55. So 5 and 55 is going to be right there. And let me check.
Excellent. You've correctly plotted the points for a distance of 1 mile with a time of 7 minutes and a distance of 5 miles with a time of 55 minutes. Now identify which scatter plot correctly represents the data in the table.
So one scatter plot or 1 point that stands out is this one, which is 1.5. See, and there's no 1.5 right here. So, and there's no 1.5 right here. So I think it's going to be again B.
That's right. Plot B correctly represents the data in the table. To draw a trend line, use a straight edge to draw a line that has about the same number of points above and below it. Ignore any outliers. Which of the scatter plots shows a trend line that meets these conditions?
So you almost look at this one has 3 on the bottom, but there's 1, 2, 3, 4, 5, 6 on the top. This one has 1, 2, 3, 4 on the bottom and 1 on the top. This one has 1, 2, 3 on the bottom and 3 on the top. So it must be A.
Excellent. Plot A has approximately the same number of points above and below the line. Now, use the trend line to predict how long it would take Joyce to run 4½ miles.
So for 4.5, I go here and then I go straight up until I hit the line and then I go across. That's right between 40 and 50, so it must be 45. Let me see, 45.
Great job! The trend line predicts that Joyce will run 4½ miles in 45 minutes. The scatter plot and trend line show the relationship between the number of chapters and the total number of pages for several books. Write an equation for the trend line. You can use 2 points on a trend line to write an equation in slope-intercept form for the trend line. The first step is to find the slope of the trend line. The line passes through points 550 and 17,170. What numbers correctly complete the slope equation?
So they said 550 and 17 and 170. So 5, I think it's going to be 17 over here and 5 over here because they said 550 and 170.
Excellent. The values of x2 and x1 in the equation are 17 and 5. Now, simplify the fraction to solve for the value of m.
So 17 minus 5 is 12, 120, and then 17 minus 5 is 12, and then 120 divided by 12 is going to be 10. So 10 pages per chapter
Correct.
approximately.
The value of m is 10. You now know that the slope of this trend line is 10. What does this number mean in terms of the problem?
So it says 10 pages per chapter. So there are 10 pages in each chapter.
Great! The slope is the relationship between the variables on the x and y axes, chapters and pages. The slope shows that each chapter averages about 10 pages. Now we need to find the y-intercept of the trend line. The equation of the trend line in slope-intercept form is y equals mx plus b, where b is the y-intercept. One of the points we used in calculating the slope had coordinates of 550. We can use those coordinates along with the slope to calculate the y-intercept. What numbers complete the equation?
They said 5 and 50. So x is the 5, and this one is the 50, and we said that the slope was 10. So m is 10.
That's right. Using the coordinates 550, the value of m is equal to 10 and the value of x is 5. You can simplify the equation by multiplying 10 times 5. What is the next step in solving for the value of b?
And remember that the equation for the line is y equals mx plus b, and we want to get the b alone, so we want to subtract 50 from both sides. So subtract 50 from both sides.
Excellent! Because 50 appears on both sides of the equation, subtracting 50 simplifies the equation and solves for b. You have used the trend line to solve for m and b. Now let's use those values to write the equation for the trend line. The equation for any trend line states the relationship between the variables. Substituting the values of m and b in the slope-intercept equation gives us the equation for the trend line relating chapters and pages. What does this equation allow us to do?
Okay, predict exactly how many pages are in the book. No, predict exactly how many chapters in the book if we know the number of pages. Yep, predict how many pages are in the book if we know the number of chapters. This one too. So predict how many pages.
That's correct. The equation for this trend line lets you predict about how many pages, y, a book will have if you know the number of chapters, x.
And remember that I went through 0, so that's why b is 0. Y equals 10x.
When you use a trend line or its equation to predict a value between data points that you already know, you interpolate the predicted value. When you make a prediction that is outside the data points that you know, you extrapolate the predicted value. Use the equation of the trend line in the previous example to predict how many pages would be in a book with 26 chapters. First, decide if this prediction is an example of interpolation or extrapolation.
So 26 is not even in here, so it's going to be extra. Extrapolation. Extra is beyond it, so it's extrapolation, okay?
Correct. Extrapolation is making a prediction that is outside the data points that you know. Now use the equation for the trend line to make your prediction for 26 chapters.
So there's 26 chapters, so it's 10 times 26, which is 260. 60, and it'll have about 260. It's still a prediction, okay?
Excellent! You've correctly used the equation for the trend line to predict that a book with 26 chapters will have about 260 pages. Now let's practice with the person.
So it says a trend line passes through 2 points on a scatter plot. How can you use the trend line to make a prediction between or outside the given data points? Use the 2 points to write an equation of a line. Substitute in the equation the value of x for which you want to make a prediction. The value of y that you obtain is the prediction. Yep, the value of y that you obtain is the prediction. Okay. Check the next one. Is it possible to draw a trend line on a scatter plot that shows no association? No, because if it shows no association, you can't tell whether, that there is an association. If the scatter plot shows no association, the data points have no relationship to each other, you can draw a trend line only when there is a linear association, okay? And you submitted, and thank you so much for watching.